In geometry, Snell's theorem states that if A, B, and C are points on a circle where the line segment AB is the diameter of the circle, then the angle ACB, is a right angle. Snell's theorem is a special case of the inscribed angle theorem. Now, as we see, we already have point A placed here. We then create point B. Connect these with a line segment and create a semicircle going through these points. We then create point C. Point C will be a free moving point along this semicircle. And as we can see, we can drag point C along this semicircle and it always stays within the semicircle. We now create our triangle. And our goal, of course, is to find out the measure of this angle formed right here. Now we know this is going to be angle ACB. We have created our midpoint O. This midpoint makes the radius of this semicircle in both directions. So AO is a radii, as BO is also a radii. But we're also going to have a third radii extending from O to point C. Now, we have created our radii. We know that all of these are going to be congruent because they are the radii of the circle and therefore measure the same amount. We now look at our angles. This big triangle, triangle ACB, is also an isosceles triangle. Therefore, its base angles both measure 45 degrees. Now, we know that in a triangle, we have 180 degrees. If we take 45 degrees, add the other 45 degrees, that would give us 90 degrees, leaving angle ACB to be a 90-degree angle. Now, as we can see, I can drag point C along this semicircle. We can see our angle measures for the base angles of this triangle change, but they always add to 90 degrees. For example, at this point, we have this angle here measuring 60 degrees. This angle over here measures 30 degrees. That adds up to 90 degrees as well, leaving this angle to be, again, a 90-degree angle. We can do this anywhere around this semicircular path. As we can see again here, if I have, for example, this to be a 70-degree angle, this one in here is 20, again, they add up to 90, creating a 90-degree angle up here to form that 180-degree angle of a triangle. This proves that, as Snell's theorem states, ACB will always be a 90-degree angle, as long as it is inscribed within the circle, or in this case, the semicircle.